Page 308, question number 3.
Draw a free body diagram for the forces on the mass in question number 2. Calculate the net force acting on the mass.
So in question number 2, we had a 9 kilogram mass. We had a force of 150 newtons going upwards, lifting it upwards, and we're going to have our force of gravity going downwards. So to calculate our net force, well, we know it's going to accelerate upwards, so our larger force is the upwards force, so 150 newtons, that I'm going to call the lift, minus our force of gravity, which is going downwards. So we have 150 newtons minus our force of gravity, which is the mass, 9 kilograms times acceleration due to gravity, 9.81 meters per second squared. So 150 minus 9 times 9.81 tells us the net force is 61.7 newtons, and the direction is positive, so it is going upwards.
Part B, calculate the work done on the mass by this net force.
Work is equal to force times distance. Our force is 61.7 newtons. Direction is up. Our direction is the same as the height, and they tell us in part 2 that that is 5 meters. So 61.7 times 5 gives us a value of 308.5 joules. That rounds to 309 joules of energy. That makes sense. Out of this 150 newtons, 61.7 newtons is the net force, so that's what's actually going to cause it to accelerate. So this is the part of that 150 newton that's actually being transformed into kinetic energy, not into gravitational potential energy. So we're expecting this to match the amount of kinetic energy that we calculated in 2C.
Question 3B, how does this relate to the answer in 2C? It's the same as the kinetic energy as I just mentioned.